you have created a programming language called Hachi. And I was just curious, what made you decide to build that? And what are the benefits to using it in case other people are interested?
So at Defiant, a lot of our stuff is a lot of it's built in C and C++ for the underlying core implementations of our networking protocols. I came to the conclusion that I wanted to have some kind of control layer that would interface with three C or C++ code bases and repositories that I can kind of try and merge together and compiled jointly. And then I was also thinking about, man, I really don't like writing C++ code or C. I love what you can do with it. They're amazing languages that are super powerful. You can do anything in it. But I don't like writing in it. So I also wanted to have a way of writing C++ kind of stuff that was a bit more automated or abstracted. Eventually that just ended up turning into a programming language because the whole idea was it was a tool. I was creating a tool for a specific need that I had, and much like Python is kind of a successor of this old language called ABC, which went defunct when Guido van Rossum, he liked it and a lot of things from it. So he brought so many of those concepts over to Python when we started writing it. I had found something similar. I found this language that was built on C++, and I thought it was really cool. It was called Pinecone. It was only around for like a year. And so I spent a long time looking through the code base and figuring out exactly how it worked. And I remember thinking there are a lot of things about it that I like. And I took a lot of that. Like I took mechanisms for implementing C++ code and being able to drag and drop it right into your file. I thought that was awesome. And so I took a lot of these things that I liked from Pinecone and brought them over into Hachi, which is kind of a successor to that in a way. So the idea is I wanted a language that was a bit lower level than Python that would allow me to compile fast machine code. And I was thinking about looking into Go for some other use cases that I was using Python for, but grew to need more speed requirements. Performance requirements. And it just became this thing that I just kept building on. And now it's a programming language that you can download, install, run. To give the definition, it is a type safe, memory safe. That's a big important thing. It implements its own auto-free when it transpiles. Type safe, memory safe, compiled language. I just released the version 0.1.3 last week. I implemented a way of compiling that would detect if there's any kind of memory leaks. So like even if Hachi itself is memory safe and it implements its own auto-free, but you can also drag and drop and just plop in C++ code or C code into the file itself, that can be unsafe. That's kind of on the onus of the developers. So you can compile it in a mode that will give you all of the detected memory leaks that's there. I released it on GitLab, and then I built a documentation site because I work on a lot of proprietary stuff. I can't just put it out there. As I built it, I guess I kind of wanted it to be out there for one to be like, hey, here's something I'm actually building in public of all my years of experience. I don't do a lot of open source stuff, and here's finally something I'm working on. If I'm the only person that ends up using it, I'm happy either way because I built it for myself. But if other people can get their hands on it and play with it, that would be cool too. Pretty much anytime that I find myself needing to do something specific, I will either build it into the language or I will build it as a core module that you can import into your file. What I like to think about it is imagine something that's a little bit between Python and Go that you can compile and is flexible and I think is fun to write in. So
yeah, we'll put a link to it. We'll make sure it's able to be found. So it's funny that you were mentioning disliking writing C code. Someone I follow on LinkedIn reshared an article from infoworld.com, and I don't know a thing about them, but the article says the White House urges developers to dump C and C++ and embrace memory-safe programming languages. The NSA specifically calls out C#, Go, Java, Ruby, Rust, and Swift as memory safe. So hearing you talk about Hachi being memory safe, right? Maybe you were in essence trying to solve that problem.
I didn't want to have to go back and free all the memory allocations that I would have to make. That was it.
Okay,
Um,
you just made it out of laziness. That's all it is. That's how most things are made.
It's also this thing too, like I didn't really want a language that I was involved with to have any kind of like inherent memory leaks from the get-go. There's a lot of language too that have memory safety mechanisms like bound checking and garbage collection, and I think Rust has a borrow system, which is actually a relatively new way of doing it, which is kind of cool, of doing memory safety. You said Python was on that list, right?
Python's is surprisingly not on the list.
Oh, okay, that's interesting. The implementation of Python is built in C. It's officially called C Python. That's the implementation that like you and I would use if we're doing something. You're not really coding in C, you're coding in this abstract language, which is interpreted with the C compiler, and then it's compiled into bytecode. Whereas if you're just writing pure C and compiling that, you compile it to machine code. I'm surprised Python is not on there though. New languages, except for maybe Zig, I think, maybe Nim. I don't know. There's a lot of really cool lower level compiled languages that are coming out. V also implements its own auto-free mechanism, which is kind of cool. It's an interesting thing because I had heard a talk by Jen Easterly, who's the director of CISA, and I was hearing her talk about memory safety in programming languages. The direction that I had thought I heard her talk about, and others too, was that do not use C and C++. And I remember taking issue with this because you should know what a memory unsafe language is before you work in a memory safe language. You should know the kinds of things and pitfalls to look out for. You should know all the kinds of foot guns that exist out there to shoot yourself in the foot, work around it and mitigate those things. So when you're working in a memory safe language, you never get that exposure to what that can be. Granted, I don't think that's like a case for like you should never use memory safe languages. I just think when you're saying that, a lot of organizations will take that to heart. Picking a software language for something, it's extremely case dependent. It's hard to make just like a big sweeping statement like that and then have it stick.